Alright, the idea here is that you should try these two questions on your own. Pause the video and then look back to the answers. A boy pulls a wagon loaded with empty bottles over a distance of 18 kilometers. 1.8 kilometers. Force applied is 35 newtons, and it's done at an angle of elevation of 42 degrees. So if there were a box of bottles here along the ground, and the boy's pulling them at an angle, and when it says angle of elevation, that's in reference to the ground, pulling at 42 degrees, and the force applied is 35 newtons. So how much work is done? Remember, work is force times distance, multiplied the cosine of the angle. So we know the force, 35 newtons. Distance is 1800 meters, so 1.8 kilometers. Multiply that by 1,000 to get your meters. And cosine 42 degrees. 46,828 joules. Or, in scientific notation, 4.7 times 10 to the 4 joules. Next example, you're pushing a lawnmower a distance of 300 meters with an applied force of 234 newtons along the handle. You're carrying out 54,000 joules of work. What's the angle of elevation? So you have your grass, lawnmower, and you're pushing it on the grass. We don't know the angle of elevation. We do know that the force applied to the handle is 234 newtons. We know how much work is done, and we know the distance. Let's start with your formula and fill in the values you know. So we know what work is, we know the force applied, we know the distance, but we need to find the angle. So filling in our values here, we'll multiply these two numbers together, our force and our distance, and we should divide that on the other side. So we have 54,000 divided by 70,200, which is the product of this multiplication. And since we want to find the angle, we use the inverse cosine. So theta should work out 40 degrees. And what you can do is take your 40 degrees, put it back in for theta, multiply all three numbers together, and you should come back with 54,000. Alright, not all cases is work going to be positive. Negative work occurs when the force applied is in the opposite direction of the motion. A truck is initially moving forward at 12 meters per second and is stopped by a braking force of 13,500 newtons, leaving a skid mark on the road that is 6.5 meters long. How much work is done to stop the truck? So we have our truck here. It's originally moving here to the left. Our braking force is applied, so force is applied in the opposite direction. And it does leave a skid mark of 6.5 meters, and that represents the distance that the brakes were working. So if you look at a free body diagram, or just the examples of the forces here, you have motion, braking force in the opposite direction. And what is the angle between the motion and braking distance? So between the motion and the braking distance, if you were to measure that angle, what would you have? Well, it's across a straight line, and everyone should know that the angle across a straight line is 180 degrees. So that's our theta. Again, think of it this way. Motion is in this direction, and if our force applied was in that direction, we would find theta in between. Here we're just widening the angle back more. Alright, let's just get rid of that. Okay, so I'll give you a moment to work that out so you can pause the video. Now hopefully you've solved it. We use the same formula. Work is force times distance cosine theta. So put in our force, our distance, and our angle of 180 degrees. Cosine 180, for those of you should cover trigonometry so far in math, and cosine 180 works out to a -1. So that's what you'd have here. So -1 times 6.5 times 13,500, and you would come back to -87,750 joules, or -8.8 times 10 to the 4. So that should only be 1 10 to the 4.